This video is for section 5-3, Simplifying Rational Expressions. Let me remind you of a property of fractions. If you divide or multiply the numerator and denominator by the same number, it produces an equivalent fraction. We use this property to reduce fractions. For example, negative 13 out of 52 can be reduced by dividing the top by 13 and the bottom by 13. Giving the answer negative 1/4. That is equivalent to the original fraction. In the second fraction, it can be simplified by reducing the 36 and 9 by dividing them both by 9 and reducing the variable factors by dividing them both by x plus 1. (36) divided by 9 makes 4, and x plus 1 divided by x plus 1 cancels away, making 1. In the bottom, 9 divided by 9 makes a 1, and x plus 1 squared divided by x plus 1 makes x plus 1. With practice, you'll start to notice fast ways to simplify fractions. For example, 36 divided by 9 cancels out, leaving 4, and x plus 1 in the numerator cancels one of the x plus 1's in the bottom, leaving one of them. In blue ink, do you see the answer is 4 over x plus 1? A rational expression is in simple form or simplest form when the GCF of its numerator and denominator is 1. Transforming into simple form is called reducing the fraction. You do that by dividing the numerator and denominator by their GCF. Here's an example problem. We have this binomial and it's being multiplied by this trinomial with a negative exponent. Let's rewrite this to help us see the fraction. The negative 1 exponent can be written as a reciprocal. Now, to help us know what the GCF is, let's factor numerator and denominator. In the numerator, we get y times y squared minus 25. The y squared minus 25 is a difference of squares and factors farther, as y plus 5 times y minus 5. In the denominator, we have a factorable trinomial. Double parenthesis pattern. 2y times y is the 2y squared. Because the last number is positive 5, possibilities are 1 times 5 or negative 1 times negative 5. The middle term is negative, so let's use the negative factors. We can put negative 1 here and negative 5 here. 2y times negative 5 is negative 10y, and negative 1 times y is negative 1y. They combine together to make the negative 11y. This doesn't factor any farther. I'm going to copy it down over here. Now that we have factored form, it's a lot easier to divide by the GCF. The only factor in common in the numerator and denominator is the y minus 5. When you divide by y minus 5, it cancels away and makes a 1. When you divide this, it cancels away and makes a 1. We can see that the answer left over is y times y plus 5 over 2y minus 1. This is called simplifying the fraction. Because there is a variable in the denominator, remember to indicate restricted values. The 2y minus 1 cannot be 0, and the y minus 5 cannot be 0. So y cannot equal 1/2 or 5. If a rational expression has a factor in the numerator that is the negative of a factor in the denominator, then reducing it also means to include a negative 1 in the GCF. Let's do an example so you see what I mean. The numerator factors as 6 times 1 minus a. The denominator factors using two binomials. 5a times a makes the 5a squared, and to make the negative 2, we need negative 2 times 1, or it's 2 times negative 1. Pick one of those choices and fill it in the blanks. I'm going to put positive 2 here and negative 1 here. Because 5a times negative 1 is negative 5a, and 2 times a is positive 2a, and that's what combines together to make negative 3a. We want to reduce the fraction, which means to look for a GCF. But right now there is no factor that's in the top that's also in the bottom. But the 1 minus a and the a minus 1 are called opposites, or negatives of each other. So we can find a GCF if we use negative 1. Let's rewrite the top as 6 times negative 1 times a minus 1. But 6 times negative 1 is negative 6. Keep the denominator the same. Now there is a common factor in the top and bottom, which cancels away. Final answer is negative 6 over 5a plus 2. Because there are variables in the denominator, there are restricted values. The 5a plus 2 cannot equal 0, and the a minus 1 cannot equal 0. Solving both, we get a cannot equal negative 2/5 or positive 1. The examples show that the variables have restricted values. When you work the book problems from this point forward, you are encouraged to identify the restricted values. However, the textbook examples and answer key are not always going to show them. Let's summarize the lesson. We reviewed how to simplify fractions, which is also called reduce the fractions. You divide the numerator and denominator by the GCF. You've done this ever since elementary school with regular fractions, but in algebra, our fractions may have variables. In this case, factor the top and bottom, then cancel out GCFs.